So now we're getting a little bit more serious with our design of Java-like string in C++. It's been probably long waiting to happen that we need to be able to simply print strings and connect them with cout just in a manner like this. Just basically be able to print this. So right now this is not going to happen, because if I try building this, our cout will complain that basically it doesn't know how to print strings. So let's overload the operator between cout type and our string type, so that we can tell cout to call specific function in case if we're trying to use this output operator to print our string. So let's give it a try. We can declare a function in the string header file, a function named operator. This is right to left shift operator originally, but we call it string insertion operator as well, or stream insertion operator. So we'll pass it parameter standard output stream reference to some kind of output stream object, and string constant reference to our string, like this. And it needs to return the same reference to the stream from as its return type. So we'll now add this to the implementation file to define this as a function with this funny name, and let's actually say that these are overloaded operators that we would like to add to the functionality of our strings, and we can keep the same comments over here. We can just even make them stand out a little bit with the comment decoration like this. And as always, just get rid of the semicolon, provide implementation of this function, and what it needs to do is simply use this output stream reference and use our string, and of course we have string view inside the string, and we simply forward it to the output operator of output stream. And this output stream also comes from, I think we need to include IOStream in this header as well, actually in this implementation file, just to make sure that this object is known. And to finish this operator, we just have to return reference to output stream back to the caller, just like this. So this is this code, this operator function, which is implemented here, allows us to use a very straightforward syntax with our strings to be able to display the content of our strings. So let's just compile it. I save everything and let's compile and see if we can. So it compiles well, and if we run this fragment, let's see what we get as our output. So now what we get as a result, of course now we're able to display the string in its entirety, and of course we're already using brand new implementation of string. Let's revisit these implementations. And so one more time, we have the call to length. This time we use string view object to tell us what is the length. Then we retrieve the character at position 0, we print h, and we also print substring. And substring begins at character position 7, which is w, and you can see that we are very nicely retrieving this part of our string. So this is a very good foundation for us to continue perhaps in experimenting with a class which behaves just like Java string, but we can use it inside C++ code, and of course we can very easily keep adding new functionality to this string. But remember, our focus right now is going to be on destructors. So let's so far we were able to do everything that we've done so far, and we never needed a destructor. We only needed these 3 different constructors to maintain basic functionality of the string. So the next function that I would like to show you could be the second version of substring, and I copy and paste this from Java documentation for the Java string class, and it supports also the index from to syntax, specifying a substring between these two indices, and it's also a constant function. So in terms of its implementation, let's add this second version of substring, which will look like this. I just again copy and paste the same, pretty much the same version, except that there is a second version of substring in the string view, where we have index from, and this is the length of the required substring. Very similar. So we have another type of substring, again to be consistent with Java interface for a Java string. So this is interesting, and we of course can test this second substring in our main function by perhaps copying and pasting this and trying. If you look at the position of the last character, for instance character 12, so this is what Java string would want to accept as a range for these characters right here. So let's just verify that the second version of our function works fine. So I'm saving all of it and building, and let's run this. So you see that this yes, oh actually that's right, according to the Java documentation, the last character is not included. It's what we have, half open range. So I apologize for this. So if I change this to 13, then we're going to get world with an exclamation point. But pretty much this is the range. So the first position is included, but the last position is not included. You can see that we're printing world without the exclamation point, which is at position 12. And it's excluded from the result.